Let's go. We're going to talk about shared compute hubs. And just before we get going, I think a lot of these terms are going to be familiar to most people here, but just for the sake of being inclusive to people who might be newer, compute, when we talk about compute, there are a few different definitions for what you can consider compute, but for the purposes of this presentation, we're going to be talking about the stacks of hardware and software that is used to support AI workloads specifically. We are then talking about the GPUs, but also the servers that they're hosted in, which are organized in racks and put in rows and then interconnected, put in huge data centers, which are the physical facilities, plus all the auxiliary equipment. So that means the power and the cooling systems as well. When I talk about the cluster, that's a large group of interconnected AI chips that are per the current training paradigms, the way that you do frontier training. So a frontier model, that's the most capable AI systems at any point. That's your ChatGPT 5.5s, the newest versions of Claude and Gemini. And when I talk about interoperability here, there's a technical definition of the interoperability, which is mostly like whether a system is able to work with the parts of another system. So let's say if you have two different software stacks, are you able to run a program using both of them or just the one? But there's also interoperability in a broader sense, because we're going to be talking about multiple countries collaborating here. So like, do the legal systems harmonize? Like if you run a program in a shared cluster, do you stay in compliance with both of them, or do you run into potential legal issues? So interoperability is also important in that sense. All right, so a little overview. We're going to talk about why compute concentration is a problem. Then we're going to explain why pooling compute makes sense for countries that are not the US and China. And then I'm going to be walking through the solution, like the legal institutional blueprint for how countries can actually do this. So some other considerations that are that we will get into if we have time. So these are questions for which we don't really have clear answers, but we are able to give some different options and trade-offs. So how to technically verify safety claims. So this ties very directly into Naci's presentation. How to navigate US export controls, which is a constraint on which countries can use compute to begin with. Whether the private sector should be involved with something like this, centralized versus federated training. How to generate public value if it's a publicly funded compute cluster, and also which countries would actually go for this. So AI compute is extremely unequally distributed. So this is from a recent report by Stanford. It shows you very clearly which regions of the world have compute, and also, just as importantly, who does not. So Africa is a big outlier here with almost no data centers. So the next slide is the same data, but as in bar form. So it shows you just how ahead of everybody else the US is. And then perhaps a bit surprisingly, China is number 4 here. That's because this is number of data centers in absolute terms. So for the purposes of AI frontier training, what we need to actually pay attention to is this supercomputer capacity. So this comes from a paper. So this is from the US Federal Reserve, but the data is taken from Epoch, from a report that I believe Jessica contributed as a typewriter, right? So a shout out to her for creating this beautiful graph. So yeah, from this graph, you can see that in terms of supercomputing capacity, the US has roughly 3 to 4 times what China has, and the rest of the world combined is represented by this green line at the bottom, and most of that capacity is concentrated in Western Europe and the Anglosphere. So meaning, for the vast majority of the world's countries, they have no AI training or even inference capacity on their own soil. So this is also from from a Stanford report. So this shows you who has ownership of the computing infrastructures in different countries. So you can see that, again, even if you build compute in your own territory, typically you will do so using either a US or Chinese infrastructure provider, your hyperscalers, the AWSs and the Google Clouds of the world. So this is a potential vulnerability because even if you're running, so let me walk that back actually. So a lot of the world's computing capacity is in the two countries we've been talking about, and many of the workloads run from abroad originate in these two countries. So during moments of political conflict, you could have a scenario where that could be turned off remotely. So if I'm a German citizen and I'm using Claude or ChatGPT, or even if I'm the German government, there's a large chance that will be run from a data center in Virginia, right? So let's say during a security or trade negotiation, that is then leverage that can be used against you, and it's not even necessary that the US government actually carries through the threat of turning off the infrastructure. Just the credible threat of that happening is a big leverage point and a potential vulnerability. And then you have this wonderful piece of legislation called the Cloud Act, which basically says that if you are a US company operating wherever in the world and you are subpoenaed by an American judge about information about person A or person B, you have to give up that data. So that if you are a German citizen, your data might be disclosed to an American judge without you even knowing this, because the Cloud Act is extraterritorial, meaning that the jurisdiction is worldwide. And as a German citizen, you're supposed to be protected by GDPR and have all these safety protections, but privacy protections. But that can happen without the German legal system ever finding out. All right. So in response to these vulnerabilities, a lot of countries are turning to sovereign AI sovereignty. However, sovereign AI, building AI in general, is very expensive. So this graph shows you the trends of what it costs in terms of hardware to train a frontier model, or just to build a cluster. So this graph is logarithmic. So you see it go from 10 million to 1 billion to 10 billion very quickly. And within the next 10 years, it's projected to reach $200 billion, which is larger than the GDP of many countries. All right, so what's the solution? A third pathway, instead of depending on foreign infrastructure or building your own sovereign infrastructure, is to pool resources. So there's a few reasons why you would do this. Part of it is economies of scale and risk sharing. There's been some research by Toby Orr at the Oxford Martin School about inference computing and how inference computing could actually become the next paradigm for in buying compute. So and just for some context, inference computing and training compute is typically different. You have different types of chips are specialized for certain workloads. So the demand uncertainty for compute is a risk factor in itself, in the sense that you could be buying as a government tons of infrastructure that might become technically obsolete within a few years. So by pooling, you share that risk. And then there's the bargaining power aspect. As a group of countries, you could have, in theory, more bargaining power in negotiating preferential terms with a hyperscaler. And then lastly, there's ecosystem integration and market formation. Like you enable some downstream innovation and can create a cluster around which talent, research, and standards can operate. So in the EU, we're already doing this. So this is the Euro HPC, the Euro High Power Computing. This is the only existing multinationally shared computing initiative that you have. So the main problem with Europe HPC is the scale. Like, this is not, I mean, it's quite impressive in its own right, and the governance is very solid, but it has not reached the scale of the private clouds in the US or China. So that's a challenge that I'm not gonna get into here. We're mostly here to talk about the institutional blueprint and the governance, which is in this case very reliant on EU laws and institutions. So our contribution, the paper, is about how do you build something like Euro HPC outside of Europe. All right, so what is the Shared Compute Hub? It consists of three main functional instruments. So the first part is a framework agreement. This can be legally binding or most likely in the beginning non-binding. This is, you can think of it as the constitution of the Shared Compute Hub. And then you have a steering committee, a board of directors if you want. This will most likely consist of member states, so government officials from each of the member states. So it has as its function to negotiate and then update the framework agreements as needed. And it is the founding agreement that provides the legal basis for the committee and empowers it to carry out its functions. The last functional instrument is what we're calling the custodian. So don't worry too much about the jargon here. This, in its simplest form, the custodian can be just a company, a project company, just created for the purposes of operating the cluster day to day. So these, in a way, does not need to be very complicated. You could start with here on the left side with just a working group that the committee coordination forum could just start as a working group hosted by, let's say, the Oxford Martin School, and then invite in government officials to start negotiating the compact, which then mandates the creation of the project company. And as kind of you build political trust and you see a proof of concept of the compute cluster actually working and the governance being solid enough, then you can scale it up. At that point, we could talk about having an international organization, kind of in the vein of the International Energy Agency. That would be then the new custodian, intergovernmental organization. At that point, also the founding agreement, the compact, would then turn into a binding treaty. All right, so I have a bunch more slides, but I think I'll just run through the next few ones quite quickly, and then if anybody has specific questions about this, I'm happy to speak more about it. So the compact, again, the founding agreement should specify which standards that should be made interoperable. Again, because we're talking about multiple countries pooling resources together and have a solid dispute resolution process. It should also codify protected quotas. So allocation is a big issue, both in terms of fairness and efficiency. So how do you ensure both? Our inspiration comes from the NC Share model in North Carolina, which is between a group of universities, where basically how it works is, as a university, as an actor, you get priority access to whatever compute you contributed. But whenever you're not using it, it can be allocated to somebody else. So this is a good way to ensure that all the compute is maximally utilized, and also prevent any impressions of it not being fair. So third part is inviolability. So because it's supposed to be a neutrally owned facility. So this becomes interesting if you're talking about tying this with a question that was asked to Naci earlier about who would run the computing, the verification agent. So one idea would it to be some sort of neutrally owned facility. So I'm happy to have a conversation about that later. But in order to codify that legally, you would need some sort of diplomatic protections of that facility and the staff that operates it. All right, so just again, try to speed up a little bit here, but the working group, they would plan where to site, which countries and locations to have the clusters, how to scale over time, like when do you refresh hardware, because again, as mentioned, it can become obsolete for at least for frontier purposes very quickly. How do you finance it, and how to align procurement processes so that you can leverage this joint bargaining point. And then lastly, the custodian, the company, project company, is responsible for governing access and allocation, ensure that you are in compliance with whatever you agreed to in terms of banned use cases to prevent misuse, and report on anything happening in terms of safety or privacy. And also, of course, implement all the shared standards in terms of schedulers, orchestration software, and make sure that governance is happening as agreed upon. So I went to this a little earlier, but you could start through a working group that leads to the signing of an MOU, Memorandum of Understanding. Then you decide on a pilot project and create a company to do it. And then you kind of rinse and repeat as you get proof of concept. All right, that's it for now. Happy to take any questions, and I do have some more slides if necessary to answer those questions. But yeah, thank you.